to the ascending limb, the ascending limb of Henle is designed a little bit differently. The descending limb, permeable to water but not salts. The ascending limb, permeable to salts but not water. So now we're really going to try to prevent water from crossing the tubule. And whatever water we've moved here, we've done that. Now as we move up, we're going to do some salt adjusting, right? Some salt balance adjusting, okay? All right, so here, right, here what we've done is we've moved lots of water out here. That means that it's going to be easy for us to passively transport sodium and chloride out of the tubule into the medulla. Right? We moved all this extra water out. While the water's out here, we can move some salt out. As we move the salt out, we increase the salt concentration of the inner medulla. And as we increase that concentration, excuse me, we get less water movement, right? Because as we increase the salt concentration of the medulla, we're making it more and more salt is moving, so the concentrations are starting to become more equal to each other. Well, once these concentrations in and out of that tubule become more equal, we get decreased movement of salt. So by the time the filtrate gets up into the outer medulla, we've done about as much passive transport as we can, so now we're switching over to active transport. Now we're actively transporting the salt out of the filtrate and into the medulla. So before, when I said, well, water moves passively, well, the reason it moves passively is because we've actively and passively transported lots of sodium chloride into this medulla, facilitating the movement, right, of water. This sets up that. Is that okay? Actively transporting salt over here sets up the passive diffusion of water in the descending limb. So far, so good? Okay. Now let's move to the distal convoluted tubule. Right? Now we've got another convoluted tubule, and then over here is our collecting duct. Okay, collecting duct. All right, now in the distal convoluted tubule, we're going to do more absorption, reabsorption, and secretion. So if you notice, what's happening in the distal tubule is a little bit different than the proximal tubule. There are some similarities. We're still doing active transport of sodium chloride, and that helps to set up the passive movement of water. We're still making adjustments to hydrogen ion concentration, which is affecting the pH of the kidney. But over here, potassium ions, that was facilitated diffusion in the proximal tubule. It's now active transport in the distal tubule, right? So whatever potassium we moved out here, right, we moved it out. Now it's like we're making a final adjustment to the amount of potassium that we want to put into the filtrate. Did we move too much of it out? Well, let's put some of it back in. Did we move out just the right amount here? Then we won't move any back in over there. Okay? Same thing with the bicarbonate. We moved the bicarbonate out passively, right? Passive transport, got the bicarbonate out into the cortex, and now we're pulling that back in actively. Okay? All right? And then as we make those final adjustments in the distal tubule, we're really mostly regulating potassium, bicarbonate, and pH. Then this stuff is going to collect into the collecting duct, and while we're in the collecting duct, we're going to make a couple more adjustments. Okay? The collecting duct is really doing the kind of last minute fine-tuning of salt concentrations. Okay? So if there's too much salt in the urine, that means not enough in the body, we'll pull some of that salt back out of the filtrate, back into the body. That's this step here, this active transport of sodium chloride. Okay? All right? That's that active transport of sodium chloride. We can also make adjustments here. This is a final adjustment to water balance. Right? We can make an adjustment about how much water is going to leave in the same way that we can make adjustments to salt. This portion of the collecting duct is permeable to water, which means we could help retain some water by concentrating the urine a little bit more to pull that water back into the body. The urea is also being passively transported out of the urine and into the kidney. Not all of it, right? Most of what you're going to push out through your urine is going to be this urea, nitrogenous waste. But this urea is passively transported into the kidney, moves through diffusion throughout the kidney, and then this is this urea over here that acts as osmotically active. So it's going to help also with this water and salt balance within the kidney. Okay? So last minute, as we either hyperconcentrate the urine, we're doing that through this final step of water balance. Then, as we move through the distal tubule into the collecting duct, the ducts from the distal tubules from other nephrons are arriving at the same collecting duct, and then multiple collecting ducts would be coming together here. There's a collecting duct, the collecting duct, the collecting duct. Those are coming together here into this large tube called the renal pelvis that then joins, or not joins together, but tapers in to this thing called the ureter, and then to the urinary bladder, and then to the urethra. Okay? All right. Okay. Make sure I've got everything here. All right, so where we are right now, this should finish off the basic excretory unit, right, this vertebrate kidney. The next thing that we could start is going to be immunology. But I'm sure you've probably figured out we are moving a little bit faster in these lectures than we would in a classroom. Part of the issue is if I get confusing, there's nobody there to stop me, to have me try to explain exactly what I mean and clarify things. So I'm just continuing to go rather than stopping and explaining. I build into my lectures time for that to happen. That's not happening now, so the lectures are more compressed. In a typical semester, sometimes I get to the immunology section, sometimes I don't. This semester I'm not going to have any trouble getting to it, but if I'm doing my math right, we have an exam day, and then we have 3 other lecture days. That's more than enough time to incorporate this last piece, which would be the immunology section. So I'm going to go ahead and stop today's lecture at the end of the excretory system, and then we'll pick up next time with the start of immunology and move forward from there. Okay? As I said before, I have no interest in adding extra material to your semester above and beyond what you would normally get in a typical class environment in animal form and function. All right? So with that, I'll say goodbye, and I'll catch you next time. Take care.